Hey guys, welcome to my channel. What we're going to be doing is we are going to be reviewing the North Carolina standards for 8th grade science. We are going to have so much fun. So guess what? I need for you guys to subscribe. I need for you guys to turn the notification bell on. And I need for you guys to like and also leave a comment. So what are we going to do? Let's begin. For another wonderful Alright guys, so you don't know, it's your boy Tashon. Alright, so let's begin. So we are going to be looking at the first standard, and the first standard is 8.P.1, and we're going to be understanding the properties of matter and changes that occur when matter interacts in an open and closed container. Now, these are the vocabulary words that is associated with 8.P.1.1. And we are going to be looking at each of these, right? What is an atom? We're going to be looking at compounds, atomic numbers, molecule mixtures, all these 12 vocabulary words. So what you can do is write these words down and ensure that you know the meaning of these words. Now, as we dive into 8.P.1.1, we are going to be classifying matter as an element, compound, or mixture based on how atoms are packed together in arrangements. Remember, guys, subscribe so that you can get all the information in the other videos that are coming up. All right? So let's begin. So these are the questions. So let's go to question number 1. What is matter? Matter is anything that has mass and takes up space. So, in other words, matter is everything on earth, because everything on earth has a mass and it takes up space, right? Everything on earth is classified as a matter because it has mass and it takes up space. Yes. So the question that I want to ask is oxygen a matter? Is oxygen a matter? Right? You can answer that question. And I would say pause it if you want, if you don't want me to tell you the answer yet. But here's the answer. Yes, oxygen is a matter. It has mass and it takes up space. Question number 2. So, what are the states of matter? Now, we should know the states of matter. The states of matter are what? Solid, liquid, and gas. As you are looking at the video to the right or the left of your page, you should see the particle arrangements, and look at the picture as well. Inside the picture, you should see where right here you have the solid. Let's see if we can get a cursor to be pointing right here. Focus point. Right, look. Solid, you see that the solid, the particles are arranged tightly. The particles are, put it this way, they are beside each other vibrating. Right. So in a solid, the particles are vibrating and they are held together tightly. They're not moving. But look, in a liquid, the particles are moving at not a fast pace, but they are slightly moving, right? They are bouncing in each other. But look at a gas. The particles are moving, they are wider. So watch this. I'm going to talk about energy now. This has the least amount of energy because the particles are jammed packed. So as you move along, you get increase in energy. The particles can move faster all over the place, right? And watch this. What am I doing to increase the energy? I am adding heat. As I add heat to a solid, what does it do? It melts. As I add heat to a liquid, what does it do? It evaporates, right? Now, there is this word that you guys must know. There is this word that you guys must know, and it's called sublimation. Sublimation is the process of the gas moving straight to a solid without turning into liquid. We must know that. All right? So, what is the states of matter? Solid, liquid, and gas. Now, let's look at number 3. Number 3 says, what is an atom? Now, an atom is the smallest particle. So an atom is considered to be the basic building block of matter. Every single matter has an atom in it, right? And another word for atom is an element. So an atom and an element is basically the same thing, right? All atoms are found on the periodic table. We are going to be going that in the other video. All elements are found on the periodic table. So an atom and an element is basically the same thing. So the atom is considered the basic building block of matter. Anything that has a mass and takes up space, and I just said it earlier, that everything on earth is a matter. So anything that has mass and takes up space is considered a matter and is made up of atom. Now, the name originally refers to particles that cannot be divided anymore. So you can't get anything less than an atom. So, for example, if I have oxygen, I can't split oxygen into anything smaller than an oxygen. An oxygen is just an oxygen, right? Hydrogen is just a hydrogen. Now, what are the atoms that, let's say, make up sugar? Sugar is simply glucose. The formula for glucose is C6H12O6. The atoms that make up glucose is carbon, C for 6, right? C, carbon, hydrogen, right? And oxygen. Good. So, what is an atom? An atom is the basic building block of matter. It is the smallest unit. Nice. Now, this is typically what an atom looks like. This is a two-dimensional drawing. In reality, the atom is not just a two-dimensional object. It is a three-dimensional. So the electrons are moving all over the atom, right? It's not just here and here. Electrons are all, we cannot just isolate an electron and say it's right here, right? It's moving all over. So this is an example of what an atom looks like. Every single atom has a nucleus, where inside that nucleus we have the protons and we have the neutrons, right? And then the next thing that is on an atom is what we call the electrons. These are called subatomic particles. Okay? So we have the nucleus, we have the protons, we have the neutrons, and we have the electrons. Right. Now, this is a diagram that you guys are familiar with, right? This is a diagram that, yes, you guys are familiar with. We have, this is an example again of an atom, and these are the subatomic particles of an atom, right? So we have the electrons, we have the protons, and we have the neutrons. Now, look at this diagram. What else do you see on this diagram? you see a plus and you see a minus and you see something that has nothing in it, right? So watch this. The electrons are negative. That means it has a negative charge. The protons are positive. That means it has a positive charge. The neutrons are nothing. Nothing is in it. That means it is neutral. It has zero charge. All right? So, what did we see again? Electrons, negative, protons, positive, and neutrons, neutral. Wonderful, wonderful. And another thing that you guys can know by looking at this diagram again, where are they placed? The electrons, you see the electrons are placed. Let me try to see if I can focus one more time. Mouse focus. All right. Here we go. The electrons are on what we call electron shells or orbitals. Yes, the electrons are on electron shells or orbitals, while the protons and the neutrons are in what we call the nucleus, right? They are in the nucleus. Wonderful, wonderful, wonderful. Let's continue. Now, another chart that you guys should be familiar with is the charges and the mass of each subatomic particle, right? So, as you see, the proton has a positive charge while its mass is 1. The neutron has no charge, but it has a mass of 1. So therefore, the protons and the neutron has mass, but the electron does not. While the proton and the electron has a charge, but the neutron does not. And it also tells you the location. So the proton is located where? In the nucleus. The neutron is located where? In the nucleus. And the electrons are located on the orbitals. Wonderful. Now, let's go to number 5. Number 5 says, what are elements, compounds, and mixtures? Remember, we said earlier that elements are the same thing as an atom. What is an atom again? An atom is the basic building block of what? All element or all matter. It's the basic building block of all matter. So if you look inside this diagram, and guess what? You will see some of these same diagrams in your EOG or maybe on your benchmark, right? So pay keen attention. Look at the elements. The elements, you only see the red, right? And you only see the blue. Now, I need to make mention of something here. If you see, are you looking? Let's focus here. Look at this one. This is all blue and this is all red. It's symbolizing that there are one type of atoms present. So therefore it's an element or one type of element present. But look at this. Some of you guys are saying, but this is 1 and this is 2. Now watch this. This is called a monoatomic molecule, while this is called a diatomic molecule. Now, diatomic molecule, which has the same element, is considered to be an element. That's what the chemistry is about it. Right? So for example, an example of a diatomic molecule is oxygen, oxygen gas. Oxygen gas is O2, meaning 2 oxygens. Another example is hydrogen, H2, 2 hydrogens. All right, so we look at elements. Elements, you see that they are the same type of unit or the same type of element. So an example of an element would be hydrogen element, oxygen element, what else? Calcium, potassium, right? You name it. And these are diatomic, which we say it's oxygen gas, hydrogen gas. Now, what are compounds? Very, 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 we have to pay very much attention here. Uh, What are compounds? Compounds are different elements coming together chemically. We have to remember that word. Compounds combined chemically to form substances, right? So if we notice, these two combine to form a substance. So, for example, hydrogen and oxygen combined to form water. Right. So, as we were saying, compounds, the main thing that you need to remember is compounds are bonded chemically. That's the main thing that you need to remember. On the EOG and on your benchmark, those are the key words that you need to remember. Compounds are bonded chemically. So, my thing is CC, compounds chemically. Now, mixtures. Mixtures are bonded physically, right? How do I know the difference between a mixture and a compound? Mixtures, you can easily reverse a mixture, while compounds, it's very hard to reverse a compound. Can you separate water? Can you separate the hydrogen and the oxygen from water? No, that is a compound. But a mixture is, let's say I have sugar and water. I mix both. I can easily get back the sugar and the water by heating. If I have, let's say, sand and water, I can easily filter the sand from the water. So, compounds, chemically bonded, hard to get back. Mixtures are physically bonded, easy to get back. So, CC, compound, chemically, mixtures, MP, which means what? Mixtures are physically bonded. Let's go to the next one. I think that's the end of it. No, wait, wonderful. We have two different type of mixtures. We need to remember these because I saw where two of these came on the EOG in 2019. Uh, we have heterogeneous mixtures and we have homogeneous mixtures. Heterogeneous mixtures, as you can see in the picture, it is not uniformed, while homogeneous mixtures are uniformed, right? You see they have a pattern. That's homogeneous. Heterogeneous, they do not have a pattern. For example, heterogeneous mixtures, you can see the difference in that mixture. For example, if I mix oil and water, that's a heterogeneous mixture. You can see the oil and you can see the water. Another example is, let's say I mix dirt with water. The dirt will stay at the bottom and the water will stay at the top. So you can see the different mixtures. Homogeneous mixture. For a homogeneous mixture, you can't see it. So if I pour alcohol in water, can you see the alcohol different from the water? No. That is what we call a homogeneous mixture. What are we going to do now? Let's look at some questions. We have 5 questions. I took 5 questions from past EOGs that could help you with this. Again, question number 1. What are the smallest unit of an element that retains the property of that element? That one's easy. Pause if you want to. But the answer is an atom. That's D. Question number 2. Structural differences between different chemicals can be represented in modules of the particle. Which drawing best represents a compound? Remember what we said a compound is? A compound is two different elements combining chemically. So what would be the answer? The answer would be A. Correct. The answer would be A. Number 3, carbon is considered an element while carbon dioxide is considered a compound. This is because carbon dioxide is what? What is it? It says, is it A gas at room temperature? No. Is it C, given off by green plants? No. Useful to humans? No. The answer is B, made of two different elements. Number 4, a pure substance that cannot be broken down into anything or any simpler substance is known as a what? We all know that one. It's a element. Good. And the last one, water is a compound. The compound H2O can be broken down into H and O by, right. So number 5, it says water is a compound. Number 5, H2O is a compound. The compound H2O, and we all know what H2O is, water, can only be broken down into what? Hydrogen and oxygen by, what's the answer? A chemical change. Because remember, compounds are chemically bonded while mixtures are physically bonded. All right, guys. So remember, subscribe so you can see the other video. Turn your notification bell on so you guys can start reviewing for your EOG. All right. See you in the next video.